Here's the current state of my Zynq-7000 board. It's been running great. I leave it running for days at a time, no issues at all. And as I've been using it, one of the things I thought I would try to experiment with is if I can run a faster part. And so this is a Zynq-7000. It's the 484 pin BGA package. And I'm using a -1, which is referencing the speed, what's the fastest speed I can run this at. And if I go out and I look at the data sheet for the Zynq-7000 here, I can see that there are a few devices. I'm using the 7020, there's also a 15 and a 10, and for those three devices I have 3 frequency options. So I'm currently using a -1, which means the maximum that I can set for it is 667, but there's also a -2 and a -3. So -3 being the fastest, I could pick up my clock speed to 866, and I would expect to be able to notice that difference. So that is then a question, what would that look like, and would my board support it? Would I have any issues with doing that? And if I go back to that picture, this is really should just be a drop-in replacement. I should be able to just populate another board. I don't want to take this one off or break this board necessarily, but populate another board and drop on a -3 instead of the -1. And that's what I've done. So I've gone out and I've populated an additional board. So exact same PCB, all the parts are identical with 3 exceptions. I changed out the part here for the actual Zynq, and I used a -3 instead of a -1. I did also go with DDR3. It's the exact same part essentially from Micron, except for it is faster capable as far as its megahertz, its speed, its clock. But that won't make any difference on this board. It just ended up sourcing wise was the same price. I just went with faster, and I'll talk about what I was thinking I might do with that in just a second, but ends up that it doesn't matter. And then I also, on the capacitors, really on the bottom side of this board, I have a lot of capacitors, underneath the Zynq itself and these other ICs. Some of the larger capacitors, I did go out and get better capacitors as far as ESR is concerned. So those are the only 3 differences really on these boards. I don't think there's anything else that should be different at all. And interestingly, I did assemble this board all in one pass and fired it up, and it tested out 100% fine, which was maybe a little amazing on my soldering side of things, just to make sure that I was pulling all the right parts and soldering everything effectively, all the different QFNs and QFPs and BGAs on this. But I was quite happy that all fired up and just booted up. So that was nice. Now, with this then, what I had to do first is, well, I guess the very first thing I did is I just popped out the SD card out of this board on the left, popped it into the right board, the faster one, and booted it up, did all my testing. But that, of course, would be using the Zynq hardware from Vivado over from this board, which was set to a slower clock. So if I wanted to get the faster clock, I have to update Vivado. So I'll just show you what I did real quickly here in Vivado. This is my project. I came into the settings, I modified the device here. So I just simply changed it from a -1, this one right here, to the -3. So pretty much everything's the same. It's just simply what's the maximum frequency I can run it at changes. I then did also go into my Zynq processing system right here. And inside of that, I changed a couple of things. First of all, the clock configuration. I changed the CPU. With the -1 part, this was limited here. I couldn't take it up to this number here. It was limited to the 667 or whatever it is. But now that I changed it to a -3 part, it lets me set up to 867. So that's what I did. I will point out, though, the DDR is still capped at 534. So even though I have DDR in the system now that is capable of much faster than that, it seems like the Zynq itself is just a limitation, a bottleneck there. And what I did just for my own notes here, and this is in a blog page that I posted and I'll be updating here shortly. There were 3 different types of memory I could pick, and I listed them here. Same with the Zynq device. So this was my original device on my original build. This is the one I'm now using on this new build with the frequencies that go with that. This was the original hardware, or the chip I used, I guess, for this DDR. And I, on the new board, use this instead. So it technically can run faster as far as the DDR itself is concerned, but this would require a frequency of 1066, which, going back to here, we can see that the limitation is 533. So not going to come anywhere close to using that. And really, even the slowest of these memory packages requires a max, or could use up to a max frequency of 800. So really, it doesn't matter. I could use any of these 3, and the performance is going to be the same on the DDR because of a limitation on the Zynq itself. It'd be great if there's a way to run that faster. I don't think there is, though. So I'm going to be running this part at 866, and then this stuff down here I'll run at the slower, whatever will speed that slower max is here, this 534. I did update CPU speed again. I did go into the DDR configuration, and I changed it from the part I had selected before. So in the DDR, I had just selected a part that was in the dropdown that was close to what I had before. Here I set it to custom, but I really didn't change anything. If I was running the actual full speed that I'd like to run for the DDR, which would get me down to this 1066 for that clock, I would have to change some of this timing. I think some of these wait states are more around the 14 instead of 7 when I get going that fast. But because I'm running a much slower clock than what the memory itself can handle, I have this all still configured to run these timings, the 777, or whichever settings here. That CAS latency would be one of them. The write latency, all of that is really the same as it was on my first board because of that slower clock coming off of the Zynq. But I made those changes. Again, the key changes were changing my settings on my project to use the new part, the -3, and then changing the max clock of the actual Zynq up to that highest speed. So I did build that, or basically go through and generate a bit stream, export the hardware, bring it into PetaLinux, and update my PetaLinux image. And so now I have 3 different SD cards I'm going to use in this video. I have one SD card for my old board that's the original as was. I have a new, basically a copy of that is what it is, that I can run on the new board. It's still set to the slower clock frequency. And then I have an updated SD card image that takes that new hardware out of Vivado into a new PetaLinux build and puts it on there. And that I'll run on this -3 board. And I would expect that this left board and the right board, using this identical SD card as far as the original image, should have the same performance. But then when I switch over to the higher clock speed, I would expect to test a higher result, get better numbers on my testing. So that's what I'm going to get into, and I'll just show you the tests I'm going to do. And I'm not going to record or go through normal speed on all of the tests, but let me do this for one. What I have right now plugged in and running is my original board with this image on the SD card that is using the original hardware, so the original clock speed for that, the -1 part. And a couple things. I have a terminal connected USB serial to my board that's running. And then I also have this connection, which is the HDMI output that I'm recording. So I'm going to use a separate keyboard and leverage that. So I'm just going to log into this system here real quick. And a couple of things I can do. Probably the very first thing I want to do is kind of take a look at maybe some performance on my, well, let's just say the processor, maybe also some of the memory, just to see how that performance changes. I was also kind of curious on, maybe a pseudo frame per second type of benchmark. And so I wrote a little script to just do some little pseudo testing there. So there's three tests that I want to run. I want to run a CPU test, a memory test, and a frame buffer device frame per second type of test. And as I do this, I'm going to track the results, and I just have a little spreadsheet down here that I'll use. And I have my three devices. So the original device, the -1, the new device with the original block design. So in other words, running at the original speed. And then the new device with the updated block design out of Vivado. So maybe the first thing I could do is just, like ls CPU. I could come over here and run ls CPU and just see what it shows. And so I can come in here and see that, okay, this is 333. And so I'm going to come in here and just mark that this was my, let's see, BOGO MIPS is what it's labeled, 333.33 megahertz. And so just a quick comment that I'm going to put in there. Let's see if there's anything else that's interesting here. I don't think anything else is going to change. So I just made note of that. I am going to maybe later record, what is the max power leverage, I think, when the system boots. I'll catch that at a later time. I'm not worried about that right now, but I will note on my benchtop power supply as I run these tests, kind of where does it pull for max power. And for the most part, I think it's going to be around the 650 milliamp, somewhere in that range is what I'm going to see or expect to see here. So then I'm going to use sysbench. And sysbench lets me come in here and do something like this. I can say sysbench. So I added this utility to my PetaLinux image, but it's sysbench. I can say I want to do a CPU run. And it's going to go out and do a bunch of calculation for prime numbers and come back with some results. And that result, I'll have to then decide which one of these do I want to use. But events per second, 32.86, that might be a good one to jot down. It ran for approximately 10 seconds. It made it through 330 events. And then I can look at some of this latency information. So somewhere in the 29-30 range. And I think I'll just make note of the 32.86. So 32.86 is my events per second. I think that kind of is telling me how fast it's running through things. And I'm going to run this a total of 4 times. So let me get over here and just run it a second time. Now I can also run this in a multi-threaded. So this being that there are 2 processors, I can run essentially 2 threads. 32.97. I'm just doing a simple. If I did want to run, and I'm not going to record the data here, but if I wanted to run sysbench with multiple threads, I could come in here and say threads equals 2. And then I could see events per second now bumped up to 65.62. So that might be interesting, and maybe I could just do a multi-threaded. So let's see, insert a column, and I'm just going to note this here. I'll clean this up later. So 6562 was one test. Okay, so I have 4 tests run doing the memory or the CPU test. So now I can also come in and do something similar with sysbench. I can do a memory run. And that came back with number of events, and let's see, total time, and maybe this million bytes per second would be the number I'm going to just track. So I'll do a 176.93. Now I could come in here and do the same thing, and I could say threads equals 2, and just to see what does that look like. And that came back with 357.43. And then I could repeat this on these other 3 runs. So let me just do that. Okay, so I ran through 4 tests. I have a CPU, single thread, double thread, memory, and double thread memory. So I have all those numbers captured. The other test I wanted to kind of see is somewhat emulate a frame per second type of test. And so I have a script, and actually I think I have a copy of it in this folder, just fps test.sh. So if I go edit that, this is what that script looks like, and you can look through this if you want. Not a big deal, but let me just quickly describe what I'm doing. I'm essentially coming in and I'm checking for a raw test file. So it's just color data that I want to draw to the screen. And again, I'm using a frame buffer device. So FB0 is the device I'm going to just write to. I'm going to manually write to that frame buffer. But this first checks to see if there is a test file of color data, and if not, it generates one. And I'm just generating a pattern with some blue and filling in color. But then after it creates the file, or if there is a file, it just uses it. It then goes out and writes out that data to the frame buffer. And it basically times it and then says, okay, over this 10-second test, how many frames could it write? And shows me frames per second. So I can now come in here, and again, I'm on my keyboard, USB keyboard connected to the device itself. I'm recording the HDMI output in this window that you see here. So I'm going to tell it to run this test, and I do need to do it as sudo. And it is creating this file, basically, if it doesn't exist. And so in this case, it's creating a color file. This is a one-time thing. And now right now, once it got done creating that, it's showing that data. And what you're seeing on the screen is it's just repeating this over and over and over. And then it got done. It said, okay, it got that done. 23 frames per second is what it was able to process. So I generate some sample data. If I run it again, and I'm just going to make note of this before I miss it. So 23 was the first run. I don't know if I would expect this to change much. The second time, the test color data is already there. So then it's just simply doing the frame per second test. And I got another 23, and I'll just run this 2 more times. Probably going to all be 23s. So in the test, I'm basically saying I can write the entire screen 23 times in a second. So that's my 23 frames per second. So this one was 24. And then I'll do one last one. So me manually writing out the entire frame buffer, and that was a 22. So I'm averaging 23 frames per second is just simply what I would go with there. A little faster on one, a little slower on one. But that's kind of a pseudo test. I'm writing the full buffer out and seeing how many times I can do that. Okay, so there I made it through one pass. Now I'm going to do this again on my original, or take the original basically SD card image and put it into the new board with the new build, but still running all the same configuration as the original. And I'm going to do the test, and then I'm going to do it again with the updated Vivado block design that runs it at the faster speed. So I'm just gonna stop kind of talking through this. These are the exact same things I'm going to do. So I'm going to fast forward here, and let's see what we come up with for results at the end of this. Now, part of this will be me rebooting or reconnecting this other system, booting up to that SD card. I probably have to copy over the latest FPS tests that I built, and then I'll run all these tests, and then I'll do the same thing on the final and third test, which is, again, the newest hardware running at the full clock speed. Okay, so made it through all those tests, and just to confirm, these were both showing the 333.33 or double that, 666 for the speed on these first two. And then when I did upgrade or change the Vivado design on the new board with the -3 part, it recognizes that. And as I do these tests, it seems like generally, a 30% increase in speed, which, is about what you would expect, right? So just validating that I am seeing that. So on the CPU, just comparing these two, so on the new hardware, the with and without the change of the clock, that's about a 30% increase. I suppose I could do something similar and divide this by the old board. So the new board running at the better speed, the old board at the original speed. And then let's just do a -1. And so this bottom number will be what is the increase from the original board to the new board at full speed. And just kind of see how those vary. So 30% pretty much across the board. Here is one that the frame per second was a 26% increase. Here with the 21. And this one was only a 12%. So that third run. And the fourth was a 22%. So it seems like on this third run, this had done pretty well for some reason on the early tests. Got 24 frames per second, and then I only got a 27 here. But so maybe on the low side, 12% increase on frames per second. On the high side, it looks like we're at 30 frames, so maybe averaging 25 frames or 25% increase in frames per second on this board. And then on the CPU, 30%, which I'm sure you could have guessed up front just by looking at the speed of the clocks, but just seems to validate that this is running, and my board seems to be handling that without any issues. Now, one thing I did not put in here is the power test side of it, but I am curious just if I come back here and I'm going to go back to my 2-thread memory or processor actually. So do this. And when I run that, I am getting 663 milliamps on that there. And I'm not going to go back to these other two right now, but 663 is basically where this is running. I think on boot it goes a little bit higher, and maybe 700-ish, so 700 milliamps. So again, 1 amp, easily carries this board and everything that's on it. So I thought that was kind of interesting to go from my original board here to this updated board here. Just really the main change is swapping out that part from a -1 to a -3, and then just a way that I could start testing it, and simply using Sysbench, using LSCPU to kind of validate that it sees the speed clockwise, and then what am I actually getting for these tests as I run. And this by no means is scientific. There could be all kinds of control items, things that are running, or other ways to impact this result in a way that would skew it. But this is just, you saw what I went through. So basically just doing some tests and recording the values. So I'm sure there's plenty of improvement that could be made there, but it just gives me a general idea that on the CPU, I am seeing this pretty much 30% across the board for increase in performance, which is great. So this will be the board that I run with moving forward. Will be this one. That other board I'll set aside and probably not use so much, since this board here, that is the -3, is going to run better. And I have, of course, I do have my sound card plugged in right now. You're not seeing that video, but everything is running fine. Audio is working great. So this will be the board going forward. And I was going to comment too on thermals. I'm still not to the point of generating really any noticeable heat coming from this. So even with the testing that I'm doing here on it, running at constant, I don't feel this picking up much for temperature at all. Like right now, everything is just still cool to the touch on the heatsink, on the sides, on the bottom. But I'll have to find some way to really stress this and let it run for 15 minutes on something, just to see if I can generate some thermal increase there, just to kind of test that out. I'm almost thinking I don't need a fan. I could just have a passive heat sink on this and be plenty fine, at least for what I've been testing so far. But that's all I had for now. Thanks for watching. Maybe this was, hopefully this was interesting, and we'll see what's up next for this board.